Now we'll talk about Routh-Hurwitz criteria, how to calculate or tabulate the Routh-Hurwitz table, Routh array rather. Um, and this is when you don't know the, the poles of the transfer function by some other means. They're not handed to you. The characteristic equation is not factored for you. Uh, the other tests don't clearly say if it's stable or not. So anyway, it all starts with the characteristic equation of the closed loop transfer function. Remember, the characteristic equation is all this. This is actually the characteristic polynomial set equal to zero, and that's the characteristic equation. So I could multiply or divide by any constant other than zero, and it's the same thing. So divide, if this isn't a positive one up here, you should divide by whatever this first coefficient is so that it is a one here. You just live with whatever else is. So, okay, we start out with the characteristic polynomial. Here's how you start the array. Well, first, you need to set up a bunch of rows. How many rows? Here, the highest power of S is 6, so we're going to need 7 rows. It's always the highest power of S plus 1. It'll be the S6 row, S5, all the way down to the S to the 0 row. That's how many rows. What goes in the first row? Whatever this coefficient is, which I say it's always 1. Should always make this term, make this whole polynomial mnemonic. So it'll be 1, then skip a term, 3, 1, 4. 1, 3, 1, 4. And then what's on the next one? It's the ones you skipped. 4, 2, 4. Put a 0 there. All right, that's the first 2 rows. You need, if this is an nth order polynomial, you need n plus 1 rows. Now, how do you compute the remaining rows? Each row is computed from the 2 rows above it. Let's take this guy. It's kind of like if you ever do 2 by 2 matrix determinants, it's going to be this product, 4 times 3 minus that product, think of an x, 2, all divided by this guy. What is this guy? We're still going to use these left 2 terms, but now we use these right 2 terms instead of these guys. So it'll be 4 times 1 minus 1 times 4 divided by 4. And then keep going one more. It'll be 4 times 4 minus 1 times 0 divided by 4. That's what we put in there. We're going to keep doing that. Well, let's do that arithmetic, and then let's do the next one. Let's see, this is 12 minus 3, or 9 over 12 minus 2. Oh, 12 minus 2 is 10. Divided by 4 for 5 halves. 0, 1. Or 4 rather. There's that 4. Now we do the same thing again. We'll do 5 halves times 2 minus 4 times 0 divided by 5 halves. And let's see, this one will be 5 halves times 4 minus 4 times 4 divided by 5 halves. Reduce, simplify that arithmetic. If you keep going, you get this. And let's see, here we don't much care exactly what it is, and we'll quickly find out why. It's some fairly large negative number. So I'll just put minus something big here, because this first column is where we get the key parts of our information. This first column of numbers. I'll explain that here. For one thing, starting at the top and going down, any sign change means it's unstable. And if this top term is always going to be 1, as I insist, by making the characteristic polynomial monic, that means if everything's positive in this column, it's stable. If you have a negative in that column, it means it's unstable. Unstable. We'll talk about zeros in that column later. There you might get marginally stable or unstable. Or stable. But each sign change going down tells you how many poles are in the right half plane. Coming down, no sign, all the positive, no sign change. Here it goes from positive to negative, and then from negative back to positive. That's 2 sign changes. That means 2 right half poles, right half plane poles. So you don't just count the number of negative signs, you count sign changes. Guess I'll do this example. It's just another example. So it's s to the 5th, so we're going to need 6 rows from s to the 5th down to s to the 0. First row is going to be 1, 30, 344, and that's it. The next row is going to be 10, 80, 480. Okay? Here's where you got to do a lot of the arithmetic off to the side. This is going to be, this term here is going to be 300 minus 80 divided by 10. It turns out to be 22. This guy is going to be 3,440 minus 480 divided by 10. That turns out to be 296. So look for some maybe tedious fractional arithmetic. And here you kind of go positive, 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 negative big to positive big, something else positive. So what do we have here? Positive to negative, negative back to positive, another 2 sign changes. So 2 right half poles, right half plane poles. It also is unstable. We'll do some more examples and talk about zeros in the right in that column. Kind of some subtle cases. We'll get to that later in another video or two.